Hello everyone and welcome back. So far we've learned anti-patterns and the only pattern is the composition root as we've discussed. And in the previous video we also touched upon the notion of constructor over-injection, whenever the constructor can get larger and larger as you add functionality into your component. And the basic culprit here is that your class is doing too much and you have to split it somehow. That's the easiest solution. And today we will be discussing another code smell, which is called a constrained construction, and I'll explain what it is in a minute. So again, we have the same example. I'm trying to keep the same examples because it would be easier for me to demonstrate how you can apply things correctly and incorrectly at the same time. So we are having avatar loader and user loader, and then we again creating logout view controller as usual. But if you never were exposed to the concept of composition root, how would you deal with this problem? So I've seen this kind of usage of dependency injection, let's say, in some of the code bases. So let's say you need avatar loader and user loader, and you're creating a logout view controller, and logout view controller needs simulated logout service. So if we are creating logout view controller inside profile view controller, we have to somehow inject an instance of logout service. And if we are creating it inside, so we need to accept it as a constructor to profile view controller as well. And it would already have 3 dependencies instead of 2, avatar loader and user loader. And then simulated logout service needs initial view controller, and initial view controller creates profile view controller, which needs all the same stuff again and again. So one of the solutions that I've seen in some of the code bases was to use a protocol that would give you access to all of the dependencies that classes need. So let me demonstrate what I mean with the example. So we have a protocol which is called services. Obviously, services withhold every service that's there in the project. So let's say we withhold into avatar loader, which is avatar image loader. We just have a getter so that we cannot set it. And then we would have user loader, and we would also have logout service, right? Okay, so we are having these 3 services inside of a protocol, and what's the purpose of doing it this way? The purpose of doing it this way so that we could just inject a single component into every class so that they could grab whatever they need. So let's see it with the example. And since we are accepting services here, we could then easily go and do like this. So we are getting avatar loader on line 69, and then we would get fake user loader. Implementation could be whatever you need. It might be a fake user loader, it might be some other like API user loader or whatnot. And logout view controller in this case also needs a logout service, right? So instead of passing the logout service and trying to fix the problem, what I've seen usually done is to just have a exactly same constructor, and then the logout service would go and do the same thing. Simple it is. And since logout view controller is creating initial view controller, it would, like, initial view controller obviously would have the same initializer, and then we would just inject services. Yeah, we need to get a cardlet here. And since we are injecting every service into initial view controller, and then it could also go and pass services into profile view controller. This is how we could potentially solve the problem of recursive navigation if we do not know, and we did not know how to do it properly with composition root by decoupling features from each other. But are we decoupling features in this case? If we go back into profile view controller, profile view controller is referencing avatar loader, user loader, and logout service, but does it actually need logout service? Obviously not, because profile view controller isn't concerned about actual logging out feature, because logging out, it lives in logout view controller, which does some network call, or like might be removing some tokens from keychain, or like removing some ID and whatnot from the local storage, let's say. And this is kind of leaky, right? Because since profile view controller isn't concerned about logout service, we are actually violating interface segregation principle, because logout service just grabs avatar loader and user loader, and the same applies to logout view controller. Logout view controller just gets the logout service, and it is not concerned about the avatar loader and user loader. So let me fix the build error pretty quick. And the only place that's broken is the composition root. Again, is the scene delegate. So what's the downside of doing this approach? So let's see it with the diagram. Again, we have our draw IO board. So let's create a profile view controller. So now, since it references only, let's say, services, which is in green, it has a strong dependency, it references it strongly, and then logout view controller also references services, and initial view controller also references this one. Just quick note here, even though we are talking a lot about view controllers, it does not necessarily mean that only view controllers could be having the same constructor. It could be any class in your project. You might constrain every class to this constructor so that they can go and easily grab whatever they need. But as you already seen, services holds reference to the avatar loader, image loader, right? Also holds reference to the user loader, and also holds the reference to logout service. But it's not actually true that only services holds reference to avatar image loader. Actually, every component now references these types. So as you can see, like the architecture is getting more spaghetti and spaghetti, because like so many arrows are pointing from components to services. Like this one references this, and then initial view controller references this, and also references so there is kind of a source code dependency of each component to some other components. So like any change on user loader, let's say we would rename the name, would break everything in the app, which is bad, of course. As you can see, constraint construction is even worse than constructor over-injection, because constructor over-injection was kind of giving you a sense that something is wrong. But looking at the code, there is just one single dependency in the view controller, right? It doesn't seem obvious that like there is something wrong. It's just like single dependency. What can be wrong with this? But if you go further, since it has only 3 dependencies, if we add more features, it would get like login, service, it would get like something, change username, service, and then this would pile up unless it gets like extremely large, and you would start experiencing lots of problems in your projects. So this is actually a constrained constructor code smell, but it's very dangerous, as you can see, because since you constrain every constructor of every component to have a single signature, as we have, like as you can see, profile view controller has services, and logout view controller also has services, and initial view controller also have services, right? Actually, there is a very similar code smell like that used in the UI kit. So init with coder, if you've ever seen NS coder, so like almost every UI kit element could be created from a coder. So if you're creating view controller, UI view, or whatever, you can simply create it from a coder. that's exactly a constrained construction code smell. So today we've touched upon the notion of constrained construction, and it is a code smell, but it's pretty dangerous, as you can see, because then you would definitely end up with a spaghetti architecture where one screen references like 5 services, like while it only needs 1, and then the other screen needs only like 3 services, while there are 5 or like 6. And this protocol would basically grow as the project would become more complex, and it would become a bottleneck at the end of the day. I guess this would be it for this video, and we've already covered a lot so far. We've already covered how we can solve the exact same problem correctly and incorrectly at the same time, and now we know the trade-offs, and then you can compare and then apply this knowledge into your own code bases to fix the problem. If it's hard for you to see like what's going on, just try to draw some diagrams. It's very simple, just requires some practice, and you would easily see what's going on there. So this would be it for this video, and thanks a lot for watching.